All right, pleasant day to everyone. I know we're going to miss class today because of the graduation, but I thought it fit to have the class recorded so that the information can still be received or disseminated. Because all the time, if we lose our class, then there's rarely ever a time to make up unless we have some other available time to everybody. Where everybody can just, really say devote to meet at that time. And then the likelihood is also difficult. So you're getting this class as a recording. So we are on module 2, and it's going, the focus is going to be on exponents and logarithms. All right, so firstly, we're going to look at exponents. Slash power slash index, right? Those are different names that we use to reference to it. All right, so it says an exponent in a mathematical notation represents the repeated multiplication of the base by itself, the exponent amount of times. So what does that mean? Take, for instance, when you have something written in what we call the index form, it is going to be, say, 3 cubed, right? Where you have the base, and then here is the exponent. Same thing as the index, same thing as the power. Now, what it does is that it tells you how many times the base is going to be multiplied by itself. So it's 3 times. Why 3 times? Because it is the exponent amount of times and the exponent is 3. So it tells us that the base is going to multiply itself 3 times, which would give us 27. Take, for instance, you have 2 to the 6. So it's going to be 2 times 2 times 2 times 2 times 2 times 2, which is the base multiplying by itself 6 times. All right. So that is what the exponent does. Now, in solving questions that uses exponents or involve exponents, we have what are called the laws of indices. Same thing as the laws of exponents, if you want to think about it that way. What we are saying here is that if you are multiplying two things and the base is the same, notice both of them have base as A, and the powers are different, you just add the powers. All right, so that is what is taking place there. Say, for instance, you are dividing two things and their base is the same, but the base is the same, the powers are different. All you do is subtract the powers. If you have a base to the power of 0, that is going to be equal to 1. Doesn't matter what the base is, doesn't matter how complex the base is. Once the power is 0, it's going to be equal to 1. Any base that you have raised to a power of 1 is equal to itself. So if we have 10 to the power of 1, that's 10, 2 to the power of 1, that's 2, a million to the power of 1, that's still a million. Anything raised to the power of 1 is equal to itself. If you have a base raised to a power that is also raised to another power, you can just multiply the powers. All right, so it's going to be a to the n, m, because n times m will give you nm. If it's two numbers, then it is the product of the two numbers. If you have a base raised to a negative power, it is the same as writing 1 over the same base to the same power, but now the power is positive. All right, so that is what you would have there. If you have a base raised to the power of a half, it is the same thing as the square root of that base. So the base is a and it's raised to the power of a half. It is the same thing as the square root of a. If you have a base raised to a fractional power, say m over n, then whatever is the denominator of the fraction is the root that you're working in, and then you get the base raised to the numerator of the fraction. So let's go again. Whatever is the denominator of the fraction, that is the base that you're working in, right? Notice the denominator of this fraction is n. So you're going to be working in the nth root, whatever that number is, and then the numerator will become the power of the base. Notice you have the base raised to a power, and the power is the numerator. If you have, say, a fractional number or a fractional term, like say, for instance, we have a over b raised to the n, then it's going to be equal to the numerator raised to the power, just as well as the denominator raised to the same power. All right. So those are rules that govern how we solve questions or how we operate in indices, right? We're going to be looking at a few questions now that will cause us to apply these things, right? And then we see what we come up with. Question 1. So we have 2 cubed times 2 to the 5th times 2 to the 6th. Say we have x to the power of 2. Right? So these are some questions that we're going to look at simplifying them. So the base is, since the base is the same, all we need to do is add the powers, right? So this is going to be 2 to the 14th, right? Since you have a power rate, you have a power raised to another power, it's going to be x to the 2 times 3, which is going to be equal to x to the 6. And over here, we're dividing and the base is the same. So all we have to do is to subtract the powers. So this is going to be 7 to the 4th. And as you recognize, our answers are still in index form. All right. All right, continuing, let's look at more questions. Say for instance, we have, oh, this one is very long. So, all right, let's look at what we have here now. So since both things are in the bracket, yes, so both of them will be raised to the power of 6. So this is going to be x to the 6, y to the 6. And that's your final answer because we're asked to leave it in index form. So that's what it would be in index form. Now notice here that we are multiplying. So the numbers will multiply and the corresponding variables will also multiply. What do we mean? 3 will multiply by 4. X squared will multiply by x. and y will multiply by y cubed. All right, so the corresponding terms will multiply. So this is going to give us 12, and you're going to add the powers. Remember, if you don't say a power, it is 1, right? How do we know this? Because this rule says anything to the power of 1 is the same thing as that thing without a power. So if you don't see a power, the power is taken to be 1, right? And then this is going to be y to the 1 plus 3. So we're going to get 12 times x cubed y to the 4th power as our final answer. These two are dividing, so the numbers will divide and the corresponding variables will also divide. But remember, when you're dividing for the variables, you subtract their powers once the base is the same. So 9 divided by 3 is going to give us 3. We're going to get x to the 4 minus 2 and y to the 2 minus 1. So this is going to give us 3x squared, y to the 1, or if you just want to write y alone, that's also fine. All right. All right, let's look at what we have here. Everything in this bracket is being squared. So the negative 5, it has a power, it is being squared. And then the x cubed is also being squared. So negative 5 squared, that's going to give us positive 25. And we're going to get x to the 3 times 2 because the power on the inside will multiply the power on the outside. So you're going to get 25x to the 6. The brackets is indicating that these things are multiplying. It's just like if you're doing binomial expansion and you get the two brackets to expand and simplify, or you simply get a term on the outside of a bracket and you have to distribute it to multiply. The brackets here are indicating that we are multiplying. So what we're going to end up with, the two numbers will multiply, right? And then you're going to have x cubed times x to the 5th multiply. And then you're going to get y to the 4th times y squared. They are multiplying. Negative 2 times negative 4 and negative times a negative gives you a positive. Sorry, I said 4 a while ago. Negative 2 times negative 7, positive 14. We're going to get x to the 3 plus 5 and y to the 4 plus 2. So we're going to get 14 x to the 8, y to the 6. And that would be our final answer. Okay, so that is what we would have for this information right here concerning multiplying these two exponential functions. Over here, likewise, same thing is happening, but now the operation has changed to division. So the numbers will divide. 25 divided by -5. X to the 7 divided by x cubed, and then y to the 4th divided by y squared. So this is going to give us right here -5, because we have a negative dividing the positive. And then this is going to give us x to the 7 minus 3 and y to the 4 minus 2. So it's going to be -5 x to the 4 y squared. So that's how we would go about simplifying exponential expressions, right? Now, there are other expressions that you can be asked to simplify that does involve exponents. And let me show you one so you can see what we're talking about. Say, for instance, just add this one in there, number 10. Say, for instance, we have 2x cubed y to the 4th to the power of 0. All right, so this is just going to be equal to 1, and let's talk about it. As complex as how this looks, well, it can be considered that way. Because it is raised to the power of 0, it's going to be equal to 1. Doesn't matter what the thing is or what the expression is. Once the power is equal to 0, it's going to be equal to 1. And that is just it. There's nothing more to it than that. All right. We could definitely go through looking at the proof as to why things raised to the power of 0 is equal to 0. But proving things are not necessarily a part of the course. It's something that we definitely could look at, but not in this, not at this time. But I'll see about looking at it so that we can get an understanding as to why. Now, to evaluate something means that you would have to come up with a final answer, right? So there must be a number answer, because that's how you're going to eventually evaluate what that thing is. Say, for instance, you are given 49 and it is raised to the power of 3 halves, right? 49 to the power of 3 halves. Now, say, for instance, you don't have a calculator and you are asked to do this. Well, somebody might be thinking to themselves, but that's not possible. May have to use a calculator to do it, because how do I raise a base to a fractional power? Because remember, the power or the index or the exponent tells you how many times the base is going to multiply by itself. So then you could ask yourself, how am I going to multiply 49 by itself 1.5 times? Why do I say 1.5? Because 3/2 is the same thing as 1.5 or 1.5. So how do you multiply the number by itself 1.5 times? Right? But if they ask you to do it and you don't have a calculator, there must be a way that it can be done. And the reality is there is. What we'll have to ask ourselves is, what number when raised to the denominator of the fraction So this is the question you're going to ask yourself. What number, when raised to the denominator of the power, gives the base? What is the denominator of the power? The denominator of the power is equal to 2. All of this right here, so is the power. Same thing as the index, same thing as the exponent. So what number, when I raise it to the denominator of the power, is going to give me 49? Why do we say 49? Because 49 is the base, right? So whatever the base is, you notice that's why I didn't put a number here. I just say 14, I just say base, because your base can change and your fraction can change. So it must gives the base. So take for instance, somebody might then say, so how am I going to know that? The reality of it is you know the numbers. So you can start by saying, is it 1? 1 to any power is still 1. Is it 2? 2 squared is 4. Is it 3? 3 squared is 9. Is it 4? 4 squared is 16. Somebody might be asking, why are we squaring? Because the denominator of the fraction is 2. So it is what number? So I'm thinking of a number. Say a number here, a number is 1. Another number is 2. Another number is 3. Another number is 4. So I'm saying what number, when I raise it to the denominator of the fraction, so the denominator of the power, right? So if I take a number and raise it to 2, is it equal to the base? And we are recognizing that none of these numbers so far is equal to the base, so we can continue trying. Is actually 7. So 7 is raised to the base. When 7 is raised to the denominator of the fraction, it is equal to the base. So what do? I know that 7 squared is the same thing as 49. So in solving this question, I can now say, instead of writing 49, I can write 7. Well, let me write back the question first. It's going to be 49 to the 3 over 2 is the same as saying 7 squared to the 3 over 2. How we can think about it is this. This 2 will cancel with this 2. How do we know that? Because this is the same thing as saying 7 to the 2 times 3 over 2. Why is that so? Because the power on the inside must multiply the power on the outside. So these 2 will multiply. So the 2's will cancel, leaving you with 7 cubed. All right. Now, 7 cubed is just simply saying 7 times itself 3 times. So, which is the same thing as saying 7 times 7 times 7, which is going to give you 343. So, we have just evaluated the question to see that the answer is 343. Now, mind you, once you have an understanding of it, some persons might skip certain steps because these two are not important. You know, some persons can just leave from here and get to here. I am explaining it to you so you can have an understanding of it. Remember, it's coming to you as a recording. So it's needful for me to pay attention to the steps so that when you get it and you have to look over it for yourself, you can actually see how we come about getting the answers that I am representing for you. All right. Say we have 256 raised to the power of 3/4. Question again to yourself. What number, when you raise it to the denominator of the fraction, is going to equal to the base? Is that number 1? So 1 to the 4th power is still 1. 2 to the 4th power is still 16. 3 to the 4th power is 81, right? Yes, 4 to the fourth power, 256. So we now recognize that the number that we're looking for is 4, because another way of writing 256 to the power of 3 quarters is 4 to the power of 4. This is the same thing as saying 256, but we know that it's raised to the power of 3 quarters. This 4 will cancel with this 4 because one is multiplying, one is dividing. Because remember, it is going to be 4 to the 4 times 3 quarters. The power on the inside must multiply the power on the outside. So these 4s will cancel. So you're left now with 4 cubed. And 4 cubed is just going to be equal to 64. We have just evaluated that question. All right, so we're looking at a case now where the power is negative. This changes nothing. We can just go ahead again. What number, when you cube it, is equal to 125? Is it 1 cube? That's still 1. Is it 2 cube? Is it 3 cube? Is it 4 cube? Is it 5 cube? So we see that the number that we're looking for is 5. So this is going to be 5 cube raised to the power of negative 4 over 3. Remember, the power and the denominator will cancel. So this is going to give us 5 to the negative 4. Now, herein comes another rule. The rule that we're looking at is the one with the negative power. Anything that has a negative power is the same as writing 1 over the same base to now a positive power. So now what we're going to end up with? We're going to end up with 1 over 5 to the 4th power. Now this is simply saying 5 multiplying by itself 4 times, right? So this is going to give us 1 over 625. All right, so that's what we would get for this answer right here. Again, question we need to ask ourselves, what number, when you raise it to the denominator of the fraction, is equal to the base? Right? So what number, when you raise it to the denominator of the fraction, is equal to the base? Is 1 to the 5th power equal to 32? That's still going to be 1. 2 to the 5th power, is that equal to 32? Yes. So I see that the number that I'm looking for is 2. So another way of writing 32 to the 2/5 is 2 to the 5th power to the 2/5. The 5 will cancel with the 5, so you're left with 2 squared, which is going to be equal to 4. All right. Let's look at one more. What number, when I raise it to the denominator of the fraction, is equal to 27? All right, so we know that that is 3 because we checked it over here. So 3 cubed is equal to 27 to the 2/3. The 3 will cancel with the 3, so you're left with 3 squared. And 3 times itself 2 times, so it's 3 times 3, which is going to give us 9, or 3 squared, 9. All right. These, as they are, they can be combined to you in a problem. Right? They can be combined to you where you have to, simplify them as a compound problem. What do I mean by that? Say, for instance, number 6, we have 6 to the negative 4 times 216 to the 7/3. Right? So we can be given like that. So what we can do is this. Let's go ahead. This is the same thing as saying 1/6 to the 4th power. All right, times, well, that look like 64. 6 to the 4th power times what number? When you cube it, it's equal to 216. All right, we never reach there, but 6 cubed is equal to 216. So 6 is the one that we're looking for. So 6 cubed to the 7/3. All right. Those will, the 3's will cancel, so we're going to get 1/6 to the 4th times. All right. We're going to keep this as is, even though we can leave it as 6 to the 4th, as 1/6 to the 4th, but it can be easily simplified this way as well. The 3's will cancel, so we're going to get 6 to the 7th. The base is the same, and you're multiplying, so you just add the power. So it's 6 to the negative 4 plus 7. Negative 4 plus 7 is going to give you 6 cubed. Negative 4 plus 7 is 3. And 6 cubed is going to give you 260. All right. From here, we learned that 4 cubed was equal to 64. Right? So we know that another way of writing it. So this is going to be 4 to the negative 2 times 4 cubed, which is 64 to the 5/3. The 3 will cancel with the 3. So those two will cancel. So you're left with 4 to the negative 2 times 4 to the 5th power. You're multiplying, and the base is the same. So you add the powers. So you're going to get 4 to the negative 2 plus 5, which is going to give you 4 cubed, which is equal to 64. Say, for instance, we have 27 to the 2/3 divided by 9 to the 3/2. Right? We already know that 3 cubed is 27. So another way of writing 27 is 3 cubed. All right. So 27 is the same thing as 3 cubed raised to the 2/3 divided by 9. Another way of writing 9 is 3 squared. Sorry, could be on the inside. 3 squared, and then 3/2. The 3's will cancel, the 2's will cancel. So you're going to be left with 3 squared divided by 3 cubed. If you're dividing and the base is the same, you subtract the power. So this is going to be 3 to the 2 minus 3, which is going to be 3 to the negative 1, right? You can leave the answer as that, or you can write it as 1 over 3 to the 1, which is the same thing as 1/3. So if you leave it as, so either of these, you can write as your answer, but it also depends on what the question says. The question can say leave your answer in index form, as well as the question can say, you know, write your answer without index. So it just depends on what the question asks you. What number square gives you 64? This is going to be 8 divided by what number square gives you 4? The 2's will cancel, leaving you with 2 cubed. So you're going to have 8 divided by 2 cubed, which is also 8. So your final answer is going to be equal to 1. All right, what number square gives you 81? That's going to be 9 squared. You still have 5 halves. And it's going to be 3 squared with 3 over 2. 2's will cancel, leaving you with 9 to the 5th divided by 3 cubed. If you want, you can still continue working it down with the 3, because the 9, you can say that that is 3 squared to the 5th divided by 3 cubed. So this is going to be 3 to the 10. 2 times 5 is 10 divided by 3 to the cube. So we can write this as 3 to the 10 minus 3, right? Which is going to give us 3 to the 7th power. And since you're evaluating, 3 times itself 7 times is going to be equal to 2,187. So that would be your final answer. What we're going to look at now is what we call solving exponential equations. Right? So we're going to be solving exponential equations. All right, so after you would have gone ahead and make sure all the bases are the same, you then will need to equate the powers and simplify. This simplifying could just basically result in a solve, yeah, or solving. Well, it says to solve, so yeah. So we're going to solve each of the following exponential equations. So we know the steps already. One, ensure the bases are the same. And then two, equate the powers and simplify. Take, for instance, we have 3 to the x minus 1 is equal to 27. Now, I have two bases here. One base is 3, one base is 27. 27 is a base. When you don't see a power, the power is taken to be 1. All right? So not because you don't see a power, you're going to say, oh, so how never solve this? You have to bear in mind, if you don't see a power, the power is taken to be 1. So here now, we're going to have 3 to the x minus 1. And we already learned from right here that 27 is the same thing as writing 3 cubed. All right. So this is going to be 3 cubed. Now look at this. We are not trying to figure out what the bases are. We can see from here that the bases are equal on both sides of the equation. So the left-hand side base is 3, the right-hand side base is 3. So we know that the bases are equal. What we're still unsure about, though, is the power. We can, look at it and by deduction, and reason, figure that the value of x is 4, but it says that you have to equate the powers to each other, and then you go ahead and solve. So x is going to be 3 plus 1, so x is equal to 4. So that's how you'd go about solving questions that involves exponents. All right, so when I look at an equation like this, I see that um, I have three different bases. I have a base that is 2, a base that is 16, and a base that is 4. Every time I'm going to ensure the bases are the same, I have to write each of the numbers to the smallest base that is in the question, right? It can be a smallest base that is in the question, or the smallest base that you can write all the numbers to, which may not be in the question, right? This equation is such that the smallest base that you can write it to is a base that is in the question, which is base 2. But there are questions that you can get that the smallest base that you can write it to is not a base that is in the question. All right. So the power of 2 here is 1. We can write 16 with a base of 2, so that's 2 to the 4th. And you still have x minus 3 on the outside. And then we're going to have 2 squared, and we still have x plus 1 on the outside. Remember, the power on the inside of the bracket will multiply the power on the outside of the bracket. So what do we have here? This is going to be 2. 4 times x is 4x. 4 times negative 3 is negative 12. 2 times x is 2x. 2 times 1, 2. Bear in mind that this 2 to the power of 1 is multiplying the brackets. Algebra means multiplication. So this 2 on the outside is multiplying the 2 on the inside to the power of 4x minus 12. And we know for sure that if we are multiplying and the base is the same, we need to add the powers. So this is going to be 2 to the power of 4x minus 12 plus 1. So this is what 4x minus 12 is 1 power added to this power, which is 1. Oh, sorry. Well, let me just change it to an arrow because I don't want to write the equation with 2 equal signs. So what we're going to have is 2 to the power of 4x minus 11 equal to 2 to the 2x plus 2. Right here, we can clearly identify the bases are the same. So all we need to do is to go ahead and solve. I'm going to keep the answer up here. I don't want to write it too far from the question itself. So the powers are going to be 4x minus 11 equal to 2x plus 2. Group the like terms. So we're going to group like terms. So all the x's are on one side, all the numbers on the next side. So we're going to get 4x minus 2x equals to 2 plus 11. This right here is going to give us 2x is equal to 13. Divide by 2. We now get that x is equal to, we can write 6.5 or we can just leave it as 13 over 2. All right? So you can leave your answer as 13 over 2. If you want to write it as 6.5, that's also okay. All right, let's look at other questions. Say we have 8 to the 2x times 4 to the 3x equals to 256. So what I made mention of earlier, right? When we said that you can write it to a smaller base that is not in the question, right? This is what I was making reference to. Please note 8 cannot be written with a base of 4. 4 to no power, well, unless it's a fractional power, we're not looking for fractional power, is going to be equal to 8. All right, so the smallest base that we can write all of these numbers to is going to be 2, and 2 is not a number that is a base in this equation. So we have one base 8, one base 4, one base 256. So here we're going to have 2 cubed, that's 8, 2 squared, that's 4, and 2 to the 8th power, that's 256. All right. So that's what we'll end up with. 3 times 2x. So this is going to be 2 to the 6x times 2 to the 6x is equal to 2 to the 8th power. These bases, these are multiplying. Base is the same, so we add the powers. So it's going to be 2 to the 6x plus 6x equals to 2 to the 8th. This is going to be 2 to the 12x equals to 2 to the 8th. And since the bases are equal, then the powers must be equal. That means 12x must be equal to 8 divided by 12. That means x is equal to 2/3. All right, let's look at this next one. We're going to have, we want to write all of these numbers to the smallest base. 27 cannot be written with a base of 9. So we have to find a smaller base. We would have already examined from the previous questions, and we know that 27 is the same thing as 3 cubed, and 9 is the same thing as 3 squared. So we can go ahead and write that this is going to be equal to 3 cubed to the power of 2x plus 3 equal to 3 squared to the power of x. And another way we can write this is going to be 27, well, 3 cubed, because 27 is 3 cubed. But now the power, one step at a time, one step at a time. Let's write it first as 27 to the 1/3. Because the power of 27 here is 1, and the root that you're working in is the third root or the cube root. So the 3 represents the root that you're working in. 1 represents the power of the base. All right. So let's simplify some stuff here. This is going to be 3 to the 6x plus 9. 3 times 2x, 6x. 3 times 3, 9. Equals to 3 to the 2x, 2 times x, 2x. All divided by 3 cubed to the 1/3. 3 times 1/3 is just 1, right? So what we're going to write it as, so we know that this in the denominator is going to be 3 to the 1, or just 3. And these two are dividing. So what we're going to end up with, 3 to the 6x plus 9 is equal to 3 to the 2x minus 1, right? Because they are dividing, so you just subtract the powers. The power is going to be 2x and the power is going to be 1. Because all of this down here is just simply 3 to the power of 1. So what you have, 3 to the 2x divided by 3 to the 1. And if you're dividing and the base is the same, you subtract their powers. Since we know here that the bases are equal, then the powers can equate them to each other. And then group the like terms, solve for x. -1 minus 9. So we're going to get 4x is equal to -10. So x is equal to -5/2. So that is what we would end up with for that answer right there. All right, let's continue looking at questions. All right, say for that was question number 4. All right, let's look at another one like this one. In this question, we can write everything to the base of 25. So it is going to be 25 squared equals to 25 to the x, all divided by, this is going to be 25 squared, so a little better, raised to the power of a quarter, because you're now working in the fourth root. So this is going to give us 25 with 6x minus 4 equals to, when this is multiplied, right? 2 times a quarter, you're just going to get a half. So what we're going to have is 25 raised to the power of a half, all divided by 25 over x. Okay? So this is going to give us 25 to the x minus a half, because you're dividing and the base is the same, so you can subtract their powers. Somebody might be asking the question, why are we working with the half? You don't have to. We could write all of them with a base of 5. And so by multiplying by 2, you would get it to be equal to 1. But I mean, if you are comfortable with your calculations, working with the half would be no different, right? So to each other. So we're going to get 6x minus x equals to negative 4 negative a half plus 4. Mhm. So we're going to get 5x is equal to 7 over 2. 7 over 2 is the same thing as 3.5. We're going to divide by 5, divide by 5. So this is going to give us x is equal to 7/10, right? Dividing by 5 is the same thing as multiplying by 1/5. So what do we mean by that? When you're dividing fractions, you keep the first fraction, which is going to be your dividend fraction. You change the sign to multiply, and the divisor, which is in our case is a whole number, you would have to reciprocate. So it's going to be 7 over 2 times 1/5. Multiplying fractions, numerator multiply, denominator multiply. That's how we get our final answer of 7/10. All right. So those are ways that you can solve those questions. Now, it does get a little bit more complex in terms of solving questions that involves exponents, and we're going to look at a few of them now. All right. Say, for instance, we have 2 to the x plus 2 to the x plus 1 is equals to 24. Now, we're going to point out a few things to you so you can follow what is happening. One of the first rules that we look at for indices says if you have a to the n times a to the m is equal to a to the n plus m. So want to draw the parallel with what we have right here. If we have 2 to the x plus 1, how would we write this in what could be considered like its expanded form, with each term, with each power having its own base? It's going to be 2 to the x times 2 to the 1, right? Because that's how we would get it. So why is it that is important? Because in order to solve this question, we are going to rearrange or restructure the question so that we can get a quadratic. So this is almost like what we call hidden quadratics. So within these questions, you can find hidden quadratics, right? And we just have to know how to simplify the question so we can get that quadratic. Some of them might not be a quadratic. Some of them might be a case that you can, once you simplify it, it's just give you a regular equation to solve. And some of them can have hidden quadratics. So there are hidden equations and hidden quadratics in some of these exponential equations that you need to find so you can simplify them to the answer. Look at this. This is going to be 2 to the x plus 2 to the x times 2 to the 1 equals to 24. Let's look at something here. 2 to the 1 is just 2, all right? We know that. Here's what we're going to do. We're going to say let 2 to the x be equal to y. We're going to use a different variable to represent it because we're solving, you know. And until we know what we're going to solve for, then there are ways that we can rearrange the question to help us to solve it. So this is going to be y plus y times 2 equals to 24. Y times 2 is going to give us 2y. And y plus 2y is 3y equals to 24. So to solve for y, that means 3 divided by 3. So y is going to be equal to 8. So y is equal to 8. But when we had the original question, were we solving for y? No, we're solving for x right here. So we can say since y is equal to 2 to the x, then this means that 2 to the x is equal to 8. What do we do when we're solving exponential equations? The base have to be the same. So this is an exponential equation, you know. So we get the base to be the same. This has a base of 2. That's the smallest base we can write to. So what is 8 with a base of 2? So it's going to be 2 to the x is equal to 2 cubed. Since we know the bases are equal, then the powers must also be equal. So the value of x that we're solving for is 3. So when x is equal to 3, this simplifying of this is going to be equal to 24, because this is going to be 2 cubed, which is 8, and then 2 to the 4th power, because 3 plus 1 is 4, 2 to the 4th power is 16, and 8 plus 16 is going to equal to 24, all right? All right, let's look at this other one. Bringing you back to something that we looked at earlier. We had mentioned that if you have a to the n and m on the outside, it's equal to a to the nm. Now look at this. We have this as 2 to the 2x. How can we write it so that it separates like this with two separate powers, we can write it as 2 squared and x on the outside. Well, there's two ways we can write it. Let's look at it two ways. So we can write it as 2 to the 2 and x on the outside, or we can write it as 2 to the x and 2 on the outside, right? Because 2 times x is still 2x and x times 2 is still 2x. Okay, multiplication is commutative on the set of real numbers, even when you're even when you have even when you have variables. So the order in which you multiply them will not change the result. Yes. So because this is a 2 to the x, we're going to use this one that is 2 to the x squared. So this can be rewritten as 2 to the x squared minus 10 times 2 to the x plus 16 equal to 0. Let y equals to 2 to the x. All right. So let's go ahead and see if we can simplify this now. We're going to have y squared, because now this is y and it is being squared, minus 10 times y plus 16 equal to 0. In this question, a is 1, b is equal to negative 10, and c is equal to 16. Remember, for the AC method, let's just quickly, for factorizing, we can say step 1, find the value of AC, and then we're going to find factors of AC that when added gives the B value, and 3, we're going to rewrite the equation. Could be an expression. We're going to rewrite the equation with the factors and simplify. Let's look at what that looks like. AC is going to be equal to 1 times 16, which is going to give us 16. Two numbers, when we multiply them, we get 16, but when we add them, we get negative 10. Negative 2 times a negative 8. Negative times a negative, positive 16, but negative 2 plus a negative 8 will give you a negative 10. What is this telling us? Positive numbers have negative factors. So every positive number will have negative factors, because two negatives multiply to give you a positive. So positive numbers will have negative factors. So we can rewrite y squared minus 2y minus 8y plus 16 equal to 0. Common between the first two terms is y. We have y minus 2 in bracket, because we would factor out the y. Now, both brackets have to be the same. And then we need to find out what number or what term do we multiply by the bracket to get negative 8y plus 16. So that's going to be negative 8. Negative 8 times y, negative 8y. And negative 8 times negative 2, positive 16. These two brackets are the same, so we factor it out. It's written once. Factor means to identify what is common, and y minus 8 make one of the factors by themselves. Remember, these are what we call our binomial factors. Binomial because each factor is made up of two terms. So what we know is that we're solving and it's equal to 0. how do we solve and get 0? So first condition, either you have 0 times 0, which is 0, 0 times something, which is equal to 0, or you have something times 0, which is equal to 0. Um, so those are instances that we look at for multiplying. Notice two things that are multiplying. So we don't know which it is. So we say either y minus 8 is equal to 0 or y minus 2 is equal to 0. So y is equal to 8 or y is equal to 2. But did we start out solving for y? No. We said let y equals to 2 to the x. So since y is equal to 2 to the x, we're now going to have 2 to the x is equal to 8 or 2 to the x is equal to 2. Since the base is the same, the power is equal. We did this one earlier. So x is equal to 3. So either x is 1 or x is 3. So trying to zoom out so we can see the entire question or the all right, so this is what we would end up with. Now, mind you, all of what is over here is not necessary for solving the question, but it's necessary for explanation purposes. And because you're watching the video, it's not prudent to just be writing down things without us having the context of how we arrive at it, right? So the over here provides some context for the solution. Yes, it's a little bit lengthy to work out, but once we have an appreciation of the context, then this becomes, manageable or easier. Okay. All right, let's continue. That was question number 7. Question number 8. All right, let's look at this one. Now, all the time you see a new question written, like I have just did on pause, it's necessary or it is important, or one could use it as an opportunity to either pause the video and try to work out the question for themselves. Yes. Going back to this rule, because we used this in the first question, in the question earlier. So this is going to be 2 to the power of 1, and then we're going to have 2 to the x, 2 on the outside. Well, let's simplify it first. 2 to the 2x times 2 cubed. So we're going to get 2 to the 1. Okay, and say let y equals to 2 to the x. So we're going to get 2 y squared times 8 plus 2 cubed is 8 plus 1. We're going to bring this over. Well, let's write it first here, and then we're going to bring it over so we can solve. So 2 times 8 is going to give us 16. So we're going to get 16y squared minus 10y plus 1 equal to 0. What do we have? We have a is equal to 16, b is equal to negative 10, and c is equal to 1. That means AC is equal to 16 times 1, 16. Two numbers, when you multiply them, you get 16, but if you add them, you get negative 10. We just looked at that a while ago. So it's going to be negative 2 times negative 8, positive 16, but negative 2 minus 8 is equal to negative 10, right? So what do we have? 16y squared minus 8y minus 2y plus 1 equal to 0. Common between these is 8. So we're going to have y minus 1, y minus 1, sorry. 2y minus 1. So we have 8y minus 1 and 2y minus 1. So either 8y minus 1 is equal to 0 or 2y minus 1 is equal to 0. Solving 8y is equal to 1. Y is equal to 1 over 8. Two y is equal to 1. Y is equal to a half. What did we do? So since y is equal to 2 to the x, we are now saying that 2 to the x is equal to 1/8, or 2 to the x is equal to a half. All right. Some persons might find it difficult. Some persons might find it difficult to see this, but you can apply the rule that says if you have a to the negative n, it's equal to 1 over a to the n. So since the fractions are written in this form, we can write it as 2 to the x is equal to 2 to the negative 1. So we know that x is equal to negative 1, right? Because the power of this 2 here is 1. So it would be written as 2 to the 1. So it's 1 over 2 to the 1. So then it's 2 to the negative 1. 8 to the 1. So it is 1 over 8 to the 1. So this can be written as 8 to the negative 1. So this is going to be 2 cubed to the negative 1, which is 2 to the negative 3. So x is equal to negative 3. So that rule can be used if you're looking at it and you're not sure how 2 to the x would be equal to a half. All right, let's look at a few more questions and then let's start here. Let me try this one. All right, so let's simplify this. So we can write it as 5 to the 2x times 5 squared plus 1 equals to 26, 5 to the x. This part we can rewrite as 5 to the x squared times 5 squared plus 1. Let's carry this over. It's going to be minus 26, 5 to the x equal to 0. Let's say y is equal to 5 to the x. You can use any variable now. So notice I'm saying let y, you can say let m, let r, let s. It doesn't matter. So this is going to be equal to y squared times 25. Let's group the terms with the y's. So it's in the general form, 26y plus 1 equal to 0. So we're going to have here 25y squared minus 26y plus 1 equal to 0. A is equal to 1, B is equal, A is equal to 25. B is equal to negative 26, and C is equal to 1. AC is going to be equal to 25 times 1, which is going to be 25. The factors of 25 that gives us negative 26 is negative 1 times negative 25. When multiplied, we get positive 25, but when added, gives us negative 26. So we can rewrite it as so we can go ahead and going to get 25y squared minus y minus 25y plus 1 equal to 0. Common here is y. So we get 25y minus 1. And we're going to get 25y minus 1. And all we need here is minus 1. So we have y minus 1 and 25y minus 1 equal to 0. So this is going to give us either y minus 1 is equal to 0 or 25y minus 1 equal to 0. Y is equal to 1 or 25y is equal to 1. Y is equal to 1 over 25. Since y is equal to 5 to the x, this simply implies that we're going to get 5 to the x is equal to 1, or 5 to the x is equal to 1 over 25. Now, we would have learned from the rules that anything raised to the power of 0 is equal to 1, right? So that means x is equal to 0. This is the same thing as saying 25 to the negative 1, which is also 5 squared to the negative 1, which is 5 to the negative 2. So that means x is equal to negative 2. So x is equal to 0 or x is equal to negative 2 is the solution for this question. Right? So somebody is asking, would it require all of this to solve the question? The only part that can be done in the background, which you not necessarily have to show, is what is done right here. Everything else is necessary for the calculation, all right? Because you have to show the factorization. If you don't want to show it in so many details, but you have to show process of the factorization, and then you have to show where you have solved for the values of x. So the only part that really not necessary is just this part right here. Okay. All right, let's work another one, and then we'll stop there. All right. So we can write this as 9 times 3 to the x squared plus 17 times 3 to the x minus 2 equal to 0. Let y equals to 3 to the x. So this is going to be 9 times y squared plus 17 times y minus 2 equal to 0. All right. A is equal to 9, B is equal to 17, C is equal to negative 2. AC is going to be 9 times negative 2, which is equal to negative 18. The factors of negative 18, that gives me positive 17, is going to be negative 18 times 1, which is negative 18, and negative 18, sorry, it has to be the other way around. And then negative 1 plus 18 is equal to positive 17. All right, so how we were working it out previously would not allow us to get the correct value of B. We would have gotten a negative 18 for the value of B, and B is a positive value. So the order in which you do the multiplication, well, not the order, the value of the numbers that we're using in the multiplication will impact the result. All right. So we're going to have 9y squared minus y plus 18y minus 2 is equal to 0. Common between these two terms is y. So we're going to have 9y minus 1. And we still need a 9y minus 1. And we're going to multiply by 2. So we're going to get y plus 2 or 9y minus 1 equal to 0. So let's look at this. Let's take it over here. Either y plus 2 is equal to 0, or 9y minus 1 is equal to 0. So that means y is equal to negative 2, or 9y is equal to 1 divided by 9 divided by 9. Y is equal to 1 over 9. So since y is equal to 3 to the x, that means 3 to the x is equal to negative 2, or 3 to the x is equal to 1 over 9. Let's look at this one. This is 9 to the negative 1, which is the same thing as 3 squared to the negative 1, which is 3 to the negative 2. So that means 3 to the x is equal to 3 to the negative 2. So x is equal to negative 2. This one here has no solution. And we can look at y. Let's choose some values for x and see if we can get a negative answer. So we're going to choose positive values, negative values, and even 0. Let's say we have 3 to the power of 0. The rule says anything to the power of 0 is equal to 1. But our answer is negative 2. Let's choose a positive value. 3 squared is equal to, all right, let's start from 3 to the 1. 3 to the 1 is equal to 3. 3 squared is equal to 9. 3 cubed is equal to 27. So we know that it's none of those answers because we passed the answer a long time ago. Because once we even reach 1, we know that we're on the side of the positive, and we need the answer to be a negative. So any power increasing in this direction, in the positive direction, is going to give us a more positive answer. So the question then is asked, why don't we use negative numbers? Let's see what happens. 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. The rule says anything to a power, a negative power, is the same as 1 over the same thing to that power. So this is going to give us 1/3. This is going to be 1 over 3 squared, which is 1 over 9. So still not getting any negative, Instead of we getting negative, we're now getting fractions. This is going to be 1 over 3 cubed, which is going to be 1 over 27. So you realize that no matter what the power is, whether it's 0, positive, or if the power is negative, we cannot end up with a negative answer. All right, so that's where we're gonna stop for today. Please feel free to write any questions you have, and you can just pass them on to me. So that I can clarify any misconception or any queries you have regarding any of the questions. All right, take care.